Hmm, why is this candy sink into my glass of water and this leaf float?
Why is it this paper boat float in the water but this coin don't?
Why is it this ball floats but this dice won't, even though they have the same weight?
Let's answer it with science!
Hello everyone! We are the
Bouncy Bunch!
And today we're going to have an exciting experiment and investigate the effects of object shape on buoyancy force.
That sounds interesting. I can't wait to see how different shapes affect the buoyancy.
What are you waiting for?
Arat na! Buoyancy is the force that opposes the weight of an object when it is submerged in a fluid, such as the water. It depends on the volume of an object and the density of the fluid.
That's right. The shape of the object can also play an important role in buoyancy. So we are going to test different shapes and see how it affects the buoyancy.
Our objective for this experiment are to observe the relationship between object shape and buoyancy force, understand how the buoyancy force depends on the volume of the object and the density of the fluid, and analyze the results to draw conclusions.
To conduct this experiment, we will need a water tank with water, Rubik's cube, ball, container, nail, styrofoam, ruler, string, stopwatch, calculator, scissor, and wheeling scale.
So, the estimated time frame for this experiment is about 1 to 2 hours, depending on how quickly we can measure and record the data.
And here are the steps we will follow for this experiment. Number 1. Fill the water tank or container with water until it is about 2/3 full. Number 2. Choose an object and weight it. Record the weight in grams. Number 3. Measure the dimensions of the object using a ruler. Record the measurements in centimeters. Number 4. Pick an object and suspend it in the water. Make sure it is fully submerged. Number 5. Measure the distance between the object and the bottom of the tank using a ruler. Record the measurements in centimeters. Number 6. Use the stopwatch or timer to measure the time it takes for the object to rise from the initial position to the surface of the water. Number 7. Repeat steps 2 to 6 for each of the different shaped objects. Number 8. Calculate the buoyancy force for each object using the formula Fb is equal to volume times rho times the Earth's gravity, where Fb is the buoyancy force, v is the volume of an object, rho is the density of the fluid, and g is the acceleration due to the Earth's gravity. And lastly, for number 9, analyze the results and draw conclusions based on the data collected.
Now that we have completed the experiment, let's discuss some post-laboratory questions to reinforce our understanding. The buoyancy
force depends on the shape of the object, as different shapes displace different amounts of fluid. Objects with larger volumes and irregular shapes tend to experience higher buoyancy forces compared to smaller or denser objects with similar volumes.
The relationship between the buoyancy force and the volume of the object is direct. As the volume of the object increases, the buoyancy force also increases, assuming the density of the fluid remains constant. This is because the larger volume of fluid is displaced, resulting in a higher buoyancy force acting on the object.
The density of the fluid affects the buoyancy force as it determines how much mass of the fluid is displaced by the object. If the density of the fluid increases, the buoyancy force also increases. As the object displaces more dense fluid, resulting in the higher upward force.
Factors that could affect the accuracy of the experiment includes the inaccuracies in measuring the weight, dimension, and distance of an object, errors in timing of the rise of an object, and variation in the density of the fluid due to the temperatures or impurities. Additionally, any air bubbles clinging on the objects or string used to the suspending of an object can also affect the accuracy of the results. It is important to ensure careful measurements and control the variables to minimize inaccuracies.
That was a fascinating experiment.
Yes, I learned a lot about how object shape can affect buoyancy force.
I agree. It was a great hands experience.
I now have a better understanding of a relationship between the volume, density, and the buoyancy force.
And always remember that the buoyancy force depends on the shape of the object.
And that's for today, and see you to our next episode.
Bye!